Hi everyone. So today I thought we could go over the differences between an aldol versus a Claison reaction. Now I get this question a lot to differentiate the two because they're very similar and they're taught in the same chapter. So let's go over the first thing that we should look out for. So what I like to do is I like to look at the reagents that I'm working with in order to figure out what type of reaction I'm starting with. So let's look at our aldol first. In the aldol reaction, you're starting with an aldehyde or a ketone, and then you're working with a catalytic NaOH or H2O, or an NaOH plus ETOH. Now, these two reagents are very important because they're not as strong as LDA, which is another reagent you learned earlier this chapter. Now, the reason we can't use LDA is because of this mechanism step right here. So the first step of the mechanism is formation of an enol, or an enolate. And we'll use our base. And that forms our enolate. Now, if I had an LDA as my starting reagent, then all of my starting material would be formed into the enolate form right here. Now, because I'm using NaOH or NaOET, it's not as strong as LDA, so therefore you'll get partially the starting material and partially the enolate that you're forming, which allows for it to attack itself. So this can come down and then push that up here to attack that and push those electrons up there. So what you will end up forming is this intermediate right here. Now, this intermediate is another good indicator of what reaction you're working with. So if you're not really sure about the starting material and you end up through the mechanism and end up at this intermediate, then you'll know that this is an aldol reaction. Now then, this intermediate can go and pick up a proton and form my final product. Now, another distinguishing factor about the aldol reaction is actually what else you can do with it. So if I applied heat to this reaction right here, then I will form something called an aldol condensation, where I get rid of the OH over here, and instead I form this double bond right here. And that is called the alpha-beta unsaturated aldehyde, or if this was a ketone, it would be a ketone. Now, in this product, this is the only way that you can form this sort of product in what you've learned so far in this chapter. So this is a really good indicator that you're working with an aldol reaction. So now let's look at our Claison. Our Claison is very similar to our aldol. We will start off by forming the enolate. Now here, if you noticed, I did not use NaOH as my starting reagent. And that is because NaOET has the matching OET portion to my starting material. Now this is important because if you remember learning in the chapter before this, the carboxylic acid chapter, whenever you have an NaOMe or NaOET, it can actually replace what's on your starting material in a nucleophilic azo substitution. So we want to prevent that, so we match the base to our starting material. So if in some accident it does happen, it will still end up with the answer that we're trying to find. So in this mechanism, we will form our enolate. And if you notice, our starting material is an ester, whereas in the aldol, our starting material was aldehyde. So now we can form our intermediate by pushing this negative charge down and attacking our previous unreacted starting material. So now you will get this intermediate right here. And for those of you that remember, this is an intermediate that you've worked with a lot, and it's called the tetrahedral intermediate. So like before, if you saw the aldol intermediate, then you would know that this is an aldol reaction. If you see the tetrahedral intermediate, then you will know that this is a Claison reaction. So then this can come and form our final product. So this final product is called a beta-keto ester. So if you were to form something that has an ester next to a carbonyl, next to another carbonyl, separated by this one carbon in between, then you will know that this is a Claison reaction. So let's summarize what we have talked about today. So when comparing between your aldol and your Claison, we would want to look at three things. The first is the reagents. Where you see an aldol, you're using an aldehyde. Claison, you're using an ester. Now, here I have a quick tip for you. What really helped me while doing these reactions is looking at the names. Now, aldol's name is very convenient because it's aldol, and this ald part stands for aldehyde, and this O part stands for alcohol. So if you look at it, that corresponds with this alcohol group and the aldehyde group that is in your product. So if you're ever forgetting which reaction it is, just look to the name and that will kind of help you differentiate. Now, Claison is just named after a guy named Claison, so just look at aldol for that. So now, after we look at the reagent, and you know that it's going to be an aldol or a Claison, then you can look at other aspects to confirm. Now, the second thing that we like to look at is the intermediate. Now, this is for when you are not really sure what you are working with, and you have to draw out your mechanism in order to figure out what your reaction is. So if for some reason you're starting with a very large compound that you can't really distinguish if it's an aldol starting material or a Claison, then you can work through the problem and do the mechanism, forming the enolate and doing protonations. And if you end up at this starting material, then you will know that this is an aldol. Or if you end up at this material, this tetrahedral intermediate, then you will know that this is a Claison. And the other thing that I like to look at is just the product itself. Now, oftentimes you will be presented with retrosynthesis questions, or one of those questions where they'll give you a compound and then ask you for the reaction to form it. So with those type of reactions, the only thing you can do is to look at the product. Now, if we looked at our product, we formed our aldol product with our aldehyde and our alcohol. And this product is actually an acetoacetic ester, which is an ester connected to a ketone or any carbonyl. So if you were to see these two different products in your starting question, then you will know that this is going to be either an aldol reaction or a Claison reaction. So I hope that this little summary was helpful for you, and I hope that you can use this on your test and your homework.